All right, this is section 3-2, properties of parallel lines. All right, so quick review. Which is the symbol for congruent? Okay, so we're going to circle the symbol for congruent, and that is this symbol here. All right, for numbers 2, 3, and 4, we're going to identify each angle as acute, obtuse, or right. So in number 2, we have a measure of 125 degrees. That's greater than 90 degrees. So this angle is obtuse. All right, number 3, this symbol indicates this is a right angle. So this is a right triangle, a right angle, excuse me. And this angle here, 72 degrees, is less than 90 degrees. So this is acute. All right. Vocabulary builder. What is the interior? Well, the interior is the inside of a figure. So some related words we might hear are inside, and the opposite would be the exterior. That is an antonym. So the definition, the interior of a pair of lines is the region between the two lines. An example, a painter uses interior paint for the inside of a house. All right, so let's use our vocabulary here. We're going to use the diagram to the right for exercise 5 and 6 and underline the correct point to complete each sentence. So in number 5, the interior of the circle contains point what? All right, so what's inside? It's going to be point A. All right, number 6, the interior of the angle contains which point? So here's the angle. What's inside the angle? That is point B. Underline the correct word to complete the sentence. The end point of an angle is called its vertex. All right, write 2 other names for angle ABC here in the diagram. So we could call this angle 1, or we could call this angle B. All right. So we have a couple of postulates here that are all kind of related in this section. So postulates 3.1 and theorems 3.1 through 3.2 and 3.3. So if I know a transversal intersects 2 parallel lines, then I actually know a whole lot of things. And we can actually explore this on, and we might do this in the lesson on Tuesday live. So corresponding angles are congruent, okay? Alternate interior angles are congruent. Same side interior angles are supplementary, and alternate exterior angles are congruent. So it's important to know what names and which angles are which, and then knowing what they are. Are they congruent or are they supplementary? Okay, so we're going to use the graphic organizer we just developed here. You may want to copy this to your notes. We're going to answer these questions. So in number 9, from theorem 3-2, angle 3 is going to be congruent to which other angle? All right, using 3.2. 3.2 says corresponding angles. So angle 3 and angle 1 are corresponding, therefore they are congruent. Okay, using theorem 3.1, which is alternate interior angles. So angle 3 and angle 7 must be congruent. Using theorem 3-3, which is alternate exterior angles, angle 1 and angle 5 must be congruent. All right, so let's see if we got our ID here. We're going to write, basically we're going to do a proof. So can you always find the measure of all 8 angles when 2 parallel lines are cut by a transversal? Well, yes. If you know one of the angles is 55 degrees, you know you can use vertical angles and find 55 degrees. Then by corresponding angles, by alternate interior angles, by linear pairs, you can actually find the angle measurements of all 8 measurements. If you know you have parallel lines, and you might see the symbol, something like this indicates they're parallel. Okay, cut by transversal. So we're going to write a statement for each angle. So why is measure of angle 7 also 55 degrees? Because these are actually corresponding angles. So the reason we would write would be corresponding angles postulate. Okay, why does angle 5 also equal angle 7? That's the vertical angles theorem. Okay, so then why does 5 equal 55? Well, notice what I just did here. I said angle 7 equals 55. I said 5 and 7 are equal. So I basically did what? The transitive property of equality. Okay. Now, how can I state angle 2 is 125 degrees? Well, angle 2 and 5 are same side interior. So they're supplementary. So these two things here are supplementary because you have same side interior angles. Okay, so then how do we know angle 4 then is got to be 125 degrees? Well, 2 and 4 are vertical angles. And that's a theorem. And then how do we know 6 and 8 are going to be 125? Well, because 6 is corresponding to 2 and 8 is corresponding to 4. So these are equal by the corresponding angles postulate. Okay. So let's try to prove a statement. So if I'm given that A is parallel to B, so that's what those red lines indicate, those red arrows, we want to prove that angle 1 is congruent to angle 7. All right, so we've got the reasons, and we're just going to write down the statements this time. So first statement, we're going to write the given. A is parallel to B. It's given. All right, so if I know that from the diagram, how do I know corresponding angles? Which ones are corresponding angles? Well, the only corresponding angles I have labeled there are angles 1 and angle 5. So we say angle 1 is congruent, excuse me, let me change that symbol, congruent to angle 5. All right. Now, if two angles are congruent, then we know that their measurements are equal. Okay. Now, what about 5 and 7? They are vertical angles. So we can say angle 5 is congruent to angle 7. Again, if you have congruent angles, those measurements must be equal. Okay. And then how do we now know 1 and 7 are related? Well, look what we just did there. 1 and 5 are equal, 5 and 7 are equal, so then 1 and 7 must be equal by the transitive property. So measure of angle 1 is equal to measure of angle 7. And then going backwards, so we have measurements are equal, we also have angles are congruent. And done, we are done with the proof. All right, let's try another proof. Okay, so find the measure of angle 1, justify your answer. So in number 14, there are two sets of parallel lines. Each parallel line also acts as a what? So here are parallel lines. So this would be a transversal, this would be a transversal, and then vice versa. So we have each set of parallel lines being cut by two transversals. Okay, so find angle 1. All right, why are 1 and 4 congruent? 1 and 4 are congruent because they're alternate interior. Okay. All right, so again, angles are congruent, measures are congruent. So congruent angles have the same measure. Now, 4 and 6 are right here. They're on the same side. They're right there on the same line, aren't they? So 4 and 6 are supplementary because of the linear pair postulate. All right. So what does the linear pair postulate state? Well, it says the sum of two angles must equal 180 degrees. So this is the definition of supplementary angles. Okay. Well, since I know 1 and 4 are equal, I know 4 plus 6 equals 180. I can substitute, okay, or use the transitive property and get rid of this. So this is the transitive property, or substitution, actually. You could say either one. Okay. All right, how do I know angle 5 is 105 degrees? Well, those are in the corresponding spots, aren't they? All right, so then why are 6 also 105? Well, 6 happens to be on this alternate interior, aren't they? Now, I know 1 and 6 are 180 degrees from this step, and I know 1 plus 105 is 180 degrees. I mean, angle 6 is 105 degrees, so I just did a transitive property here, or a substitution. So substitute into statement 5. And then lastly, if I subtract 105 from both sides, I get angle 1 equals 75 degrees. So this is called the subtraction property of equality. All right. So we just did 2 very good proofs. Now you're going to have to do a couple proofs on your own. I'm going to do a couple homework problem proofs for you, but you need to really practice proofs just so you get the hang of them. All right, now let's use some algebra here. All right, so the bases of a trapezoid are parallel. Okay, notice these indications here. So this is a trapezoid. The bases of a trapezoid are parallel. We're going to use same side interior angles postulate to complete the statement. So parallel lines cut by transversal, these 2 angles must add to be 180 degrees. So 2x plus x minus 12 equals 180 degrees. And then 3y plus y plus 20 equals 180 degrees. So we're going to solve both of these equations now. So for the first one, we have 2x plus the quantity x minus 12 equals 180 degrees. Simplifying, we have 3x minus 12 equals 180 degrees. We're going to add 12 to both sides, so 3x equals 192, and divide by 3, and we get x equals 64. On the right-hand side over here, we have 3y plus y plus 20 is going to equal 180 degrees. So we're going to simplify. We have 4y plus 20 equals 180 degrees. Subtract 20, so 4y equals 160. Divide by 4, y equals 40. And there we go. X and y are now solved. All right, let's see if we understand what we're talking about here. So circle the best name for lines A and B. Here's line A and B. Notice the red little arrows there. These must be parallel lines. So then what are the best names for 1 and 8? 1 and 8 must be just on the same side of the transversal. 1 and 8 are on the outside. So we can call them same side exterior angles. All right, and at this point, here's some key vocabulary words that you should be able to prove, and you should be good to go.